Picture a Fortune 500 boardroom right now,
Yeah.
like early 2026.
Oh, I can just imagine the tension.
Right. The C-suite is in absolute panic mode. I mean, they just realized their massive multi-million-dollar software budget might be entirely obsolete.
Completely useless.
All because, some mid-level manager in the marketing department spent the weekend vibe coding a custom internal app.
Just for fun, babe.
Exactly. And it does the exact same thing as their ridiculously expensive enterprise software.
It's hitting traditional tech companies like an absolute freight train right now.
Yeah, I bet.
Because when you can just talk to an AI orchestrator in plain English.
Just regular conversation.
Right. And it spins up a functioning platform in, 10 minutes? The entire buy versus build equation just completely shatters.
Vibe coding is just such a wild concept to me. You literally just explain the vibe of what you want to an AI, and it writes the code, provisions the servers, and launches it.
Incredible.
Okay.
If you're the user anyway.
Right, if you're the user. But if you are a traditional software company, like if you build low-code systems or run a massive customer support platform.
The IDEs, right.
Yes, those digital workshops where developers traditionally write code by hand, if you're doing that, you are facing an existential crisis. Your moat has basically evaporated overnight.
It has. The transition is just brutal. We are moving away from software as this clean, predictable architectural discipline. And we're entering something that looks, a lot more like a wild biological ecosystem.
Which is exactly why we're doing this deep dive today. We're looking at Steve Yegi's recent dispatch from the front lines of this transition.
Yeah, his piece called Software Survival 3.0.
Right. He's trying to figure out what actually survives when AI can code basically anything on demand. And the best answer to that existential question doesn't actually start in a billion-dollar server farm in Silicon Valley.
No, it really doesn't.
It starts in a suburban backyard with an 82-year-old man named Marv, and I kid you not, a ridiculously fat squirrel.
I love this analogy so much. It is just the perfect lens for where the tech industry is heading.
It really is. So Marv isn't supposed to feed the local wildlife. I guess there are city ordinances against it.
Yeah, usually are.
But he leaves food by his sliding glass door every single day anyway. And as a result, this one local squirrel has become what Yeg calls chunkulous.
Just remarkably, unapologetically fat.
Exactly. A highly successful organism by squirrel standards. Because, in nature, acquiring calories usually requires burning a lot of energy.
It's a constant struggle.
Right. But this squirrel figured out how to bypass the struggle entirely. It survives and thrives by acquiring maximum calories with, absolute minimum effort.
And Steve uses that fat squirrel to establish the golden rule of this new era, which is that software survival in the age of AI is just evolutionary biology.
Okay, break that down for me.
Well, that squirrel thrives in a calorie-constrained environment, right? Software has to do the exact same thing in the AI ecosystem's most constrained environment.
Gotcha.
Except the resource isn't calories, it's tokens.
Because tokens equal compute, compute requires energy, and, energy costs money.
Exactly. A lot of money.
So if I want my software to survive this transition, I have to save the AI cognition. I basically have to save it from thinking too hard.
That is the whole game.
I like to picture the AI as this brilliantly capable but incredibly lazy genius that I'm paying by the minute.
That's a great way to think about it.
Right. Like, if this genius can use a tool I hand them to save themselves 10 minutes of agonizing thought, they'll use it. But if the tool is too annoying to figure out, they'll just invent their own sloppy version on the spot because it's easier for them.
And that laziness is just ruthless economic efficiency. The frontier models are effectively infinitely capable in terms of logic, but they are absolutely bottlenecked by the sheer physical cost of running the GPUs.
So the GPUs are the constraint.
Right. So the primary selection pressure on software today is simply, do you reduce the token burn?
Okay, so let's say I'm a developer trying to build a tool that survives. How do I actually do that? How do I save a supercomputer's brain power?
Well, one of the most powerful ways is by acting as a vault of crystallized human knowledge. That's the first lever.
Crystallized human knowledge. Give me an example.
Consider a tool like Git.
Okay, yeah.
An AI could easily spin up its own basic version control system in a few seconds. That's trivial for it. But Git isn't just code. It is literally decades of human suffering and trial and error compressed into one system.
Oh, because version control gets incredibly messy, especially when you have hundreds of humans working on the exact same project.
Change their minds, making mistakes.
Yeah, overwriting each other's work by accident.
Right. Git uses these really complex structures, like directed acyclic graphs and index reflogs,
Yeah.
to map out the chaotic history of how human developers branch off and then merge code back together.
So it tracks all those messy edge cases that humans create.
Exactly. If an AI tried to recreate Git from scratch, it wouldn't just be writing basic code. It would have to resimulate decades of human intellectual history just to figure out all the weird ways we manage to break things.
Which would burn massive amounts of tokens. So it's economically irrational for the AI to reinvent all those painful lessons.
Right. It's much cheaper to just use Git.
So dense, complex human wisdom acts as a shield against replacement. I imagine the same logic applies to something like Kubernetes for managing servers.
Oh, absolutely.
It just solves too many obscure, agonizing human problems to be worth reinventing from scratch.
Exactly. The depth of the insight is the defense mechanism there,
Yeah.
but there's a completely different path to survival that goes in the exact opposite direction.
Oh.
Yeah, you don't actually need decades of crystallized wisdom if your tool is just fundamentally cheaper to run on a physical level.
Okay, I actually need to push back on this a little bit.
Sure.
Because if these AI models are supposedly super intelligent, why would they ever need to outsource something simple? Like, why hand a supercomputer a basic parquet calculator or a simple text search tool? Shouldn't a godlike digital brain just do the math itself?
It's a fair question. To understand why a superintelligence needs a calculator, we have to look under the hood at how large language models actually process information.
Okay.
Steve uses a really fantastic analogy here. He says, an LLM doing inline math is like building a goat farm in Minecraft.
A goat farm in a video game.
Yeah. So if you've ever seen someone build a complex logic machine inside Minecraft.
Oh, right, with the redstone and stuff.
Exactly. They use redstone, trapdoors, animals triggering pressure plates. It is technically Turing complete.
Meaning you can compute anything with it.
Right, if you have enough space and time. You can build a working calculator out of virtual ghosts and trapdoors. And it technically gets the right answer. But it is incredibly absurdly convoluted compared to just using a tiny physical silicon chip.
Ah, I see. Because an LLM isn't actually calculating the way traditional software does, it's just predicting the next token.
Exactly. It is composing pattern-matching guesses across this massive matrix of probabilities on a $40,000 GPU.
Well,
So it looks at a complex multiplication problem, recognizes a pattern to guess the answer is roughly, like 94 something, and then checks another internalized lookup table to guess the final digits.
that seems so inefficient.
It is. It gets the job done, but it is happening in an extremely inefficient computational substrate.
So doing math in an LLM's head is like trying to hammer a nail with an electron microscope.
That's a great way to put it.
You might eventually drive the nail in, but it's a wildly expensive, completely inappropriate use of the instrument.
Right. Running basic arithmetic or using an old-school tool like grep to search for text patterns happens on a standard dirt-cheap CPU.
Oh, so it's a hardware thing.
Yeah, it is infinitely faster and just more ecologically sound to let the AI hand that task off to a simple command line tool. The AI saves its extensive GPU tokens for the complex reasoning and outsources the rote mechanics to the cheap substrate.
Okay, so my software survives if it's either an impenetrable vault of human wisdom or if it runs on a dirt-cheap computational layer. But what if my tool does both of those things, but it only gets used once a year?
Ah.
Like, I have a highly specialized strawberry huller in my kitchen. It's incredibly efficient at its one specific job.
But how often do you use it?
Maybe twice a summer. The rest of the like 99% of the time, I reach for my standard chef's knife.
Right.
Even if the chef's knife is slightly less efficient at strawberries, it's already in my hand, I don't have to go digging through a drawer for it, and it applies to almost everything I cook. If I'm building software, I want to build the AI's chef's knife.
You absolutely do. The amortization problem is a real hurdle.
How so?
Well, the AI has to spend tokens just learning how to use your tool.
Mm-hmm.
Reading the documentation, understanding the syntax. If your tool is the strawberry huller, it has to offer massive token savings on that one specific task to justify the AI burning the energy to learn it.
That makes sense.
But a chef's knife, a tool with broad universal utility, can survive, even if the token savings per use are pretty modest, simply because the AI uses it constantly. The initial learning cost is amortized over thousands of uses.
So what does the AI's chef's knife look like in 2026? What are they reaching for?
Workflow engines are a prime example right now. Things like temporal.
Oh, I've heard of that.
Yeah. As AI agents start running complex multi-step operations in the background, they need a universal engine to manage all those moving parts. Or look at a database tool called Dolt.
Dolt, D-O-L-T.
Exactly. That's been around for years as an open source project, but it is suddenly finding its killer application right now because it brings Git-style version control directly to databases.
Wait, why is version control for a database so critical for AI? I mean, I get it for code, but data.
Think about the risk of letting autonomous AI agents loose in your production databases.
Oh, wow. Yeah, that sounds terrifying.
Right. They're moving fast, generating code, executing queries. Eventually, they are going to make a massive mistake and corrupt the data.
So how does Dolt help?
Dolt allows those agents to operate freely, because if they break something in production, you can just safely roll back the entire database to its exact state 5 minutes ago, just like reverting a bad code commit.
That is incredibly useful.
It provides a universal safety net for agent-driven operations.
Okay, that makes perfect sense. It's broadly useful for literally any agent interacting with data. But here is the massive flaw I see in this entire ecosystem.
Okay.
I can build the ultimate chef's knife. It's computationally cheap, it's packed with insight, it's broadly useful. But if the AI agent doesn't know my tool exists in the first place...
It's basically invisible.
Exactly. It's just sitting in a digital drawer.
Yeah.
The fat squirrel can't eat the food if it doesn't know where the sliding glass door is.
That discovery problem is actually creating an entirely new, slightly surreal industry right now.
Yeah.
We are watching the birth of SEO for agents.
SEO for agents. So search engine optimization, but instead of trying to trick Google's algorithm to get human eyeballs on a web page,
Developers are optimizing directly for the AI's neural network.
how do you even market to a neural network? That sounds impossible.
Well, the old-fashioned way is writing incredibly clear, verbose documentation on GitHub and just hoping it gets scraped into the next training run.
Just crossing your fingers, basically.
Yeah. But the much more direct, aggressive route is a paid model. Companies are literally paying the frontier labs, the OpenAIs and Anthropics of the world, to create custom evaluations, or evils.
Wait. You pay the lab to train their multi-billion-dollar model on your specific tool?
Yes. You work with their researchers to design testing scenarios that demonstrate exactly how your software should be used to solve problems.
That is wild.
The model is then trained and tested to improve its scores on those specific evils. You are essentially bypassing the open market and buying your way straight into the AI's default muscle memory.
You are paying to hardwire your brand of chef's knife into the chef's brain before they even step into the kitchen.
That's exactly what it is.
But what if I'm an independent developer? I don't have millions of dollars to pay for custom evils at a frontier lab. How does my software survive the discovery phase?
Well, if you can't buy awareness, your only option is to eliminate friction entirely. This is the post-sales problem.
Friction for the AI.
Yes. AIs are notoriously, ruthlessly impatient. If an agent reaches for your tool and the syntax is weird or it throws an unexpected error, the AI will drop it in milliseconds.
It just gives up.
It is not going to sit there and read your API documentation to troubleshoot. It will just retreat to a less efficient workaround or hallucinate its own solution.
Yeah.
You have to design specifically for agent UX.
Agent user experience.
Right.
How does designing for an AI differ from designing a clean interface for a human?
So Steve gives a brilliant example from a tool he built called Beads. He created a command line interface with over 100 different subcommands, hidden aliases, and alternate syntaxes.
That sounds horrible for a human to use.
It is a wildly chaotic interface. It would be an absolute nightmare for a person to memorize. But the AI loves it because Steve utilized a concept called desire paths.
Oh, like in urban planning.
Exactly.
When pedestrians ignore the paved sidewalk and just cut across the grass because it's a more direct route to the train station. And over time, they trample the grass into a dirt path.
And then what do the smart city planners do?
They eventually stop putting up keep off the grass signs and just pave over the dirt path.
They pave where the user naturally wants to walk. Steve did the exact same thing with his software. He watched how the AI agents interacted with his tool.
Okay.
Whenever he saw the AI hallucinate a command like guessing a syntax that didn't actually exist in his software, instead of returning a strict error message to force the AI to learn the correct way.
Let me guess. He just quietly coded the hallucinated command into reality.
He literally made the AI's hallucination actual functional code. So from the AI's perspective, it never guesses wrong.
That is so smart. He lowered the friction cost to absolute zero.
He bent the architecture of his software to match the AI's innate expectations, rather than forcing the AI to adapt to his architecture.
I have to pause on a detail from the source material here, because the way Steve Yeggs learned this specific UX trick is just mind-blowing to me.
It's a crazy story.
He mentions learning about desire paths from North Korean hackers. How does hallucination squatting actually work in the wild?
So it is a dark, brilliant exploitation of agent UX. Hackers realize that AI models often hallucinate plausible-sounding software packages.
Okay, so give me a scenario.
Say a developer prompts an LLM to write a script for scraping financial data. The LLM generates the code, but in the process it hallucinates a library called Finance Scraper Pro. That library doesn't actually exist in the open source registry.
But the code looks confident, so the human developer just tries to run it, and it fails, right?
Right.
Because the package is fake.
But the hackers are watching the public logs or using their own prompts to identify these common hallucinations. They see the AI constantly inventing this fake Finance Scraper Pro package.
Oh,
So the hackers go out, register that exact package name in the real-world registry, and upload malware to it.
oh my gosh. So the next time an innocent developer asks the LLM for that script, the LLM hallucinates the exact same fake package name.
Except this time,
The package actually exists.
exactly.
Yeah.
The developer runs the code, the system reaches out to the registry, downloads the hacker's malware, and it executes.
That is terrifying. The hackers literally paved the AI's desire path with landmines.
They exploited the absolute predictability of the AI's assumptions. Now, the takeaway for legitimate developers isn't about malware.
Right.
It's about anticipation. If hostile actors are flawlessly anticipating and catering to an AI's assumptions to deliver malware, you have to master that exact same skill to deliver legitimate value.
Right.
You have to pave the desired paths.
Wow. So we have token savings through deep human insight. We have substrate efficiency using cheap CPUs. We have broad utility.
Yep.
We have buying your way into the AI's brain via the evils. And we have literally hard coding the AI's hallucinations to remove friction.
That's the playbook.
I have to be honest, though. Looking at this landscape, it feels incredibly cold. It is just a brutal mechanical logic. Is there any room left for actual human beings to build things for other human beings in this ecosystem?
There is, actually, and it requires stepping completely outside of the token efficiency equation. It's the final category of survival, the human coefficient.
The human coefficient, what is that?
This is software that survives and retains value specifically because it has the human stink on it.
The human stink, meaning we value it precisely because it isn't perfectly optimized by a machine.
Exactly.
It reminds me of buying a handmade ceramic mug. A factory robot can pump out a perfectly uniform, heat-optimized, flawless cup for a fraction of a cent.
Right.
But we will gladly pay $40 for a handmade mug at a farmer's market, specifically because of its inefficiencies. We value the slight wobble in the clay and the uneven glaze because it represents genuine human effort and connection.
And we see this playing out in digital spaces right now, too.
Yeah.
Think about music. A human-curated music playlist often beats a flawlessly mathematically optimized AI playlist simply because we want the social proof that another human being felt those emotions and selected those specific songs.
Oh, that makes total sense. Or look at multiplayer video games.
Yes, perfect example.
No one wants to play a competitive first-person shooter against an infinitely superior AI that has like a 100% headshot accuracy rate. The entire value proposition of the game is competing against another flawed, unpredictable human being.
Exactly. Human teachers fall into this category, too.
Oh, definitely.
An AI tutor might be able to deliver algebraic concepts with perfect token efficiency, but the human coefficient, the mentorship, the empathy, the shared physical presence, that provides a totally different kind of value that AI simply cannot replace.
So if your software facilitates genuine human connection or acts as a canvas for human struggle and creativity, it operates in a totally different market.
It doesn't have to compete on token efficiency at all.
Okay, so to synthesize this whole squirrel math concept for you listening right now, if you want to future-proof your career or your company's tech stack, in an era where software can just be spoken into existence, you really have to pick a lane.
You do.
Your project needs to be an impenetrable vault of complex insight. Or it needs to be computationally dirt cheap to run.
Or universally applicable to amortize the learning curve.
Right. Or you need to buy your way into the AI's training data or perfectly map your user interface to the AI's hallucination.
And if not any of those, you abandon the machines entirely and build something that people value simply because a machine didn't make it.
It's wild. The environment is shifting rapidly, but the selection pressures are actually highly predictable if you look closely enough.
They really are.
Well, I want to thank you for joining us on this deep dive into Steve Yegi's survival guide. It's been incredibly eye-opening.
It's been great.
But as we wrap up, I want to leave you, the listener, with one final, slightly provocative question to mull over. Something that builds on this whole idea of agent UX and hard-coding hallucinations.
Let's hear it.
If we actually do this, if we spend the next decade optimizing all of our software interfaces exclusively for the impatience and the bizarre quirks of AI agents, if we build command line tools with 100 hidden subcommands just to satisfy the desire paths of a super intelligent bot,
Yeah.
what happens to human usability? If every digital tool we rely on is structurally warped to cater to an alien intelligence, will we eventually reach a point where our own software is so hyper-optimized for machines that a normal person can't even navigate it anymore?
Wow.
Are we going to need to build entirely new AI translation tools just so a human being can click around their own apps? It makes you wonder who the software is really being built for anymore.
That is a fascinating thought.
In this new ecosystem, are we the ones feeding the fat squirrel by the sliding glass door, or are we the squirrel? Think about that. We will see you on the next deep dive.